Okay, students, good morning. Kindly tell me, am I audible or not?
Yes, sir.
Yes, sir, audible.
Okay, just a second, I will share my screen. Okay, and is my screen visible?
Yes, sir, it is visible.
Okay, okay, okay. Okay, so in the previous class, what we did was we just studied the basics of computer networks. We studied the topologies. We studied how computers are connected to each other. We studied half duplex, full duplex, simplex connections, and all every kind of things. We were also studying the network devices. So we covered till the switches, right? But I guess in your lab classes, Wang Mang, Pinaki sir, as well as Arpan sir has already told you about the network devices that we use in our day-to-day lives. Still, I will not cover those, but still, I have the PPT for that. So it was the PPT that we could not cover due to the lack of time. But I will give the PPT in the Google Classroom. The PPTs are very self-explanatory, so just go through them. If you face any problems regarding those PPTs, so kindly contact me via call or via WhatsApp. So you can always do that. Okay. So since we are behind schedule because the previous week was a holiday, so today we will be covering the most important topic in computer networks, that is the reference models. Okay. So first and foremost, we should understand that why do we need a layered architecture. Okay. So obviously we use concept of layers in our daily lives. Okay. So what's an example of that? So as an example, let us consider two friends who want to communicate through postal mail. Okay. So in the process of sending a letter to a friend would be complex if there was no service available from the post office. So that is obviously the reason that if a post office was not there, then we couldn't have, we won't be able to send a letter to from one person to another person. Now let us look at the layers that are involved in the task of sending a letter. Okay. So first and foremost, a sender will write the letter, put it in an envelope, and then drop it in the mailbox. Okay. So that is the higher layer. Okay. So if I come to the middle layer, the letter is carried from the mailbox to the post office, and if I come to the lowest layer, so it means that the letter is delivered to a carrier by the post office. Okay. Now what the carrier will do, so suppose you are sending a letter from Kolkata to, suppose for example, Ranchi, so the carrier will go from Kolkata to Ranchi. Okay. Now after it goes to Kolkata from Ranchi, it will deliver the letter to the post office. Now what will the post office do? The post office will carry this letter from the post office to the mailbox. Okay. And now after it reaches your mailbox, what the receiver will do in Ranchi, it will just pick up the letter from the mailbox, it will remove the envelope, and then it will read it. Okay. So these are the tasks involved, the layered tasks that are involved in sending a letter from a person A to a person B. Okay. Now if I apply the same logic in the case of computer networks, so we come to reference models in that case. Okay. So there are two reference models in computer networks that we will study today. So the first one is known as the ISO OSI reference model, and the second one is known as the TCP/IP model. Okay. So just see the term reference model. So if I say ISO OSI, it's a reference model, but if I say TCP/IP, I will not say that it's a reference model. So why I am saying that ISO OSI is a reference model and TCP/IP is not? So we will come to that later in the session. Okay. So the ISO OSI reference model in this case was established in the year 1947. Okay, and it was made available by the International Standards Organization, that is the ISO. So that is why the reason that's the reason why the name is ISO and OSI reference model. Okay. Now ISO, obviously, as we told you earlier, that it stands for the International Standards Organization, and the OSI in this case means Open System Interconnection. Okay. Now just remember this name very carefully, that OSI in this case it will mean Open Systems Interconnection. Okay. Now why it is called open, why it's an open standard, we will discuss it later in the session. Okay. So it was first introduced in the year 1970. Now again, as we said earlier, that we should keep a note that ISO is the organization and OSI is the model. Okay. So the name is ISO OSI, where ISO is the organization and OSI is the model. Okay. Now the ISO ASI reference model has 7 layers. Okay, so let's start from the bottom. The first layer is the physical layer. The second layer is the data link layer. The third one is the network layer. Fourth one is the transport layer. Fifth one is the session layer. Sixth is the presentation layer, and 7 is the application layer. Okay. Now we will go through each and every layer one by one, and we will understand what are the functions of each and every layer. Okay. So if I take this diagram, so we can see okay, so 7 layers are present in every computer. Okay, so if I take this diagram, and we can see that here the communication is taking place between the sender and the receiver. Okay, so obviously the sender will have these 7 layers, and the receiver will obviously have this 7 layers. Okay, now again, so you can see that whenever a sender is sending a message or a packet or a suppose for example an email from the sender to the receiver, what will the sender do? The sender will first use the application layer. Okay, now what is the function of every layer, we will understand one by one. So first let us see this diagram. So whenever a sender is trying to send a mail, it will first use the application layer. Okay, now the mail from the application layer, it will travel to the presentation layer, then it will travel to the session layer, then it will travel to the transport layer, and then it will travel to the network, the data link layer. Okay, and after it comes to the data link layer, it will go to the physical layer. Now this physical layer is responsible for the actual sending of the message. Okay, so the actual sending of the message from the physical layer will be through the physical medium. Now whatever physical mediums we use, if you remember, we use either fiber optics or coaxial cables or twisted pair cables. Okay, so these are the physical mediums. So from the application layer, the message will pass through the physical medium, and then it will go to the receiver side. Okay, now just see the difference, that if the sender is sending a mail, it will start from the application layer, right? So it will start from the bottom from the top to the bottom. Okay, but in the case of the receiver, after the mail is received through the physical medium, what will happen? So the mail first will go to the physical layer. Okay, and then from the physical layer, step by step, it will go to the application layer, and then it will go to the receiver. Okay, so with this diagram, we can understand that whenever a sender, which means a person who is the sender, is trying to send a mail, he or she will communicate with the computer with the use of the application layer, right? Similarly, the receiver side, after the mail shifts from the physical layer to the application layer, what will happen is that the receiver, the person who is sitting at the receiver side, will obviously communicate with the computer with the help of the application layer. Okay, now every layer between the two computers, the communicating computers, will use some protocols. So what are the protocols known as? They are known as peer-to-peer protocols. Now what are protocols? Protocols means a set of rules. Okay, so obviously whenever a sender is trying to communicate with the receiver, we will obviously use a set of rules to do that. Okay, also whenever we are talking about a single layer, for example at the sender side, let us look at the session layer, that is the 5th layer. Okay, so the session layer will take some service from the transport layer, from the layer at below itself, and it will give some service to the layer that is above itself. So the session layer will take services from the transport layer, and the session layer will give service to the presentation layer. So this is the scenario. Okay, so in that scenario, so whenever a layer is taking service from the bottom layer and it is giving service to the upper layer, so there should be again some set of rules by which it can provide services. Okay, so in that scenario, these rules between the layers are called as what? Interface. But whenever we are talking about rules of communication between one layer at the sender side and one layer at the receiver side, we will say that they are not interfaces, but in this case it will be what? Protocols, peer-to-peer protocols. Okay, now let us understand the function of each and every layer one by one. So first and foremost, we have the physical layer. Okay, now from the diagram you can see that the physical layer is actually responsible for the actual communication of the message. Okay, so obviously actual communication of the message is in binary bits. So you can see that from the physical layer, the data is coming from the data link layer, right? So the actual message will be sent through the transmission medium. After it is being sent from through the transmission medium, it will go to the physical layer at the receiver side, and then from the physical layer at the receiver side, it will go to the data link layer at the receiver side. Okay. Now obviously the physical layer is responsible for the movements of individual bits from one hop to the next, okay, or one node to the next. Also, there are some other functionalities of the physical layer as well. So the physical layers are also concerned with the type of the transmission medium, right? So obviously, whenever we are suppose we are using a fiber optic cable, so both the computers who are connected with the help of a fiber optic cable will have some set of rules, right, to communicate through the fiber optics cable. So again, if it is communicating through a coaxial cable, so again it will have a different set of rules. Okay. So the physical layer is always concerned with the type of transmission medium that is being used for the communication. Okay. Again, it is concerned with the representation of the bits. Okay. So the physical layer data consists of a stream of bits. So obviously we have seen in the diagram that it consists of a sequence of zeros and ones. Okay. So to be transmitted, these bits must be encoded into signals. Okay. Electrical signals or optical signals. Now, what are electrical signals? What are optical signals? We will study this in the later half of the session. Okay. So to get transmitted, it needs to be converted into signals. So the physical layer will define the type of encoding. Okay. Now there are various types of encodings that we will study, like Manchester encoding, DNZ encoding, and these kind of things. So we will study NRC encodings and everything. So we will study these encoding schemes in the later half of the session. Okay. It is also concerned with the data rate, right? Which means at how much speed the data will go from the sender to the receiver. So that is also a concern of the physical layer. Also, synchronization of bits, which means if I am sending a 1 and a 0, it cannot happen that the receiver will receive the 0 first and then the 1. It will have to receive the 1 first and then the 0. Okay. So the synchronization of the data bits from the sender side to the receiver side will be maintained with the help of the physical layer. Also, the physical topology is also the concern of the physical layer, which means what topology we are using. Either we are using a star topology or a bus topology. So these kind of things will also be overseen by the physical layer. Again, the transmission mode as well, simplex, half duplex or full duplex. So what transmission mode we will use, that will also be governed by the physical layer. Okay. Okay, now let's come to the next layer, that is the data link layer. Okay, so from the diagram you can see that the data link layer at the sender side will receive data from the network layer and it will send data to the physical layer. Okay, and similarly at the receiver side, what will happen, that it will receive data from the physical layer and it will send data to the network layer. So again you can see that every layer, so if I consider this layer, you can see that apart from the data we have two more things, that is H2 and T2, right? Why 2? 2 is because that is the layer number. And what is H and T? This is known as, H is known as the header and T is known as the trailer. Okay. Now what are the concepts of header and trailer? We will discuss them later in the session. Okay. So for now let us understand that the data link layer is responsible for moving frames from one hop to the next, right? Now what is frames? You can ask. So if I say that we have a sentence that I want to go to college, right? So if this is the data and we convert it into binary bits, so it will be a long binary bit of zeros and ones. Okay. Now how will the receiver understand that which binary bits represent I? How will the receiver understand that which binary bits will represent want? Again, some binary bits will represent to, some binary bits will represent go, right? And some binary bits will represent school. Okay. Now how will the receiver understand this? So for this, what will the data link layer do? It will break the whole message into certain frames. Okay, and every frame will be followed by a header at the front and a trailer at the bottom, at the end. Okay, so how do we do this and everything, we will study this in the later half of the session. So for now you understand that a data link layer is responsible for moving frames from one hop to the next. Okay, with the help of headers and trailers. Okay. So there are some other responsibilities as well. So first is framing, that we told you earlier. The data link layer divides the stream of bits received from the network layer into manageable data units called as frames. And again, every frame will be followed by a header at the front and the trailer at the end. Okay. Also, the physical addressing is governed by the OSI mode, by the data link layer, which means if you remember, it has been discussed in the lab as well that there are various types of addressing. So the initial one is known as a MAC addressing, right? And that is actually the physical address. Okay. Now this physical addressing scheme will also be taken care by the data link layer. How? We will discuss it later. Okay. Also, a data link layer has a very important function known as error control, right? So in the case of error control, there will be two parts. The first one is error detection, and the second one is error correction, right? So which means, so whenever a sender is sending some data, right? So suppose during the sending of the data through the physical medium, the data gets lost or the data gets garbled, okay? So the receiver data link layer will have the functionality to first detect the error, and then if possible it can also correct the error, okay? So again, this functionality of error detection as well as error correction, that is known as error control, will be taken care by the data link layer, okay? Also it has another functionality called as access control, which means when two or more devices are connected to the same link, okay? So it can happen that both the devices are trying to send data at the same time, right? So again, it is the responsibility of the data link layer that which node will be able to send the data. So whether it will be a simplex connection, whether it will be a half duplex connection, or again whether it will be a full duplex connection. So this again will be governed using access control by the data link layer, okay? Now next is the network layer. So again we can see that at the sender side, the network layer will receive data from the transport layer and will send data to the data link layer. So again at the receiver side, it is the vice versa, okay? Again you can see from the diagram that the data is there, and again the network layer also is adding some header to the data, right? Which means every layer to the data, it will add some headers, right? And what are these types of what are the headers, what are the information stored in the headers? We will discuss it whenever we go to the actually we go to the details of the each and every layer in the OSI model, okay? So again you can see that the network layer is responsible for delivery of individual packets from the source host to the destination host. So let us give you a scenario that whenever we are talking about network layer, we are talking actually about internet protocol, right? Which means IP address. So again, if I don't, if a message does not have a IP address, right? Which means it will have a sender IP address from which sender it is coming, and it will have a receiver IP address to which receiver it is going, right? So if I don't have the IP address in this, so suppose let us say that the header contains the IP addresses of the sender as well as the receiver. So again, if I don't have the IP addresses, it won't be possible to actually send a message or actually deliver a message, okay? So again, the network layer is actually responsible for what? For delivery of individual packets from the source host to the destination host, okay? Just a second. Now there are some other functionalities of the network layer as well. So the first one is actually logical addressing. So again, as we discussed earlier, there are two types of addresses or various types of addresses. So the first one we discussed was the physical address. That does not change, that comes with the computer itself, right? Actually not the computer, we can say that it comes with the NIC card, that network interface card, okay? So it comes actually with the NIC and it cannot be changed. So that is the physical address. The second one is what? The logical address. So in this case, the logical address means the IP address. So it will remain same, the IP address will remain same throughout a communication, but it can change, right? So if I am trying to send data from one computer to another computer, so the IP address won't be changed, right? But if I end this session and the next day again I want to send data from a computer to another computer, the logical address can change, right? So we can say that the physical address is static, the logical address is static but not always. Why? Because throughout a connection, the logical address will be static or the IP address will be static. But whenever we are closing the connection and again we are trying to send data from one node to another node the next day, we can change the IP address or the logical address can be changed, right? So this is the responsibility of the network layer, the logical addressing part. Okay. Next we have something called the routing. Okay. So again, if you remember the function of switch or the function of router, we said that the router can be responsible for routing the packets from one destination to various destinations according to the routing table that we have. Okay. Now, what are the function? What are routing tables? What are the function of actual function of routers? We will again discuss this in the later half of the session. So again, when independent networks or links are connected to create inter-networks, so whenever we are having inter-networks or large networks, the connecting devices, often called the routers or the switches, route or switch the packets to the final destination. Okay. So again, this feature also will be taken care by the network layer. So why? Because the network layer is actually responsible for delivery of packets from the source to the destination, right? The data link layer and the physical layer will help the network layer in delivering the packets, but actually the responsibility of delivering the packets from source to the destination will be taken care by the network layer. Okay. Next we have the transport layer. So again, you can see from the diagram that it receives data from the session layer and sends data to the network layer. Again, you can see that it is adding some headers. Okay. So the transport layer is actually responsible for what? For the delivery of a message from one process to the another. Now, what do we mean by process? Let us understand first. So we know that there is another kind of a addressing scheme that is known as port address. Okay. Now, what's the port address? Now, so suppose whenever we are having a computer, so various processes are running at the same time, right? So similarly, at the receiver end as well, various processes will be running at the same time, right? So suppose one process out of suppose 100 processes in my computer want to communicate. Suppose we are saying that FTP process, that is file transfer process of my computer, is trying to communicate with the FTP process of the receiver computer. Okay. Now obviously my FTP process will have a port number. Okay, and the receiver FTP process will have a port number, right? So suppose we are saying that the FTP port number is 27, for example. Okay, so I will have the IP address, I will have the physical address, that is fine. But if I don't have the specific port address, I will not be able to communicate with the FTP protocol at the receiver side, right? Because if I am sending a file to the receiver side using a FTP protocol, the receiver again has to receive the file in its computer using the FTP protocol, right? So which means if I am sending data using port number 24, 27 in my computer, that at the receiver side it will have to receive data using port number 27. Okay, so this port number 27 or the FTP protocols that I am saying, or the processes that I am saying, will be the communication between the process of my computer to the process of the receiver computer will be taken care by the transport layer. Okay. Okay. Again, other responsibility of the transport layer is what? Segmentation and reassembly. So a message is divided into transmittable segments that we have discussed earlier. So which each segment contain a sequence number. Okay. So these numbers enable the transport layer to reassemble the message correctly upon arriving at the destination, right? Now it can happen that suppose we are sending a message and the message has been segmented into suppose 10 frames. Okay. Now it can happen that all these frames will not go to the receiver side sequentially. It can happen that we are sending the first frame, then we will send the second frame, then we will send the fourth frame, and so on. Okay. If I give an example, all of you must have used torrent, right? So whenever we download files using torrent, we can see that various chunks of these torrents are downloaded at the same time, right? And at the end, it will say that it will reassemble everything and then give it back to you. Okay. So that is the function of the transport layer. So every chunk, it is not necessary that it will go to the receiver at a sequence. It can happen that certain frames will go first, certain frames will go second. Okay. And after all these frames are received at the receiver side, so following the sequence number, it will reassemble everything and then give it back to the receiver. Okay. So this is also the function of the transport layer. Again, the next layer is the session layer. So the session layer again is responsible for dialog control and synchronization. Now what is dialog control? Let us understand. The session layer allows two systems to enter into a dialogue. So it allows the communication between two processes to take place in either half duplex or full duplex mode. Okay. And again, what is synchronization? If you can take an example of suppose we have entered into a website, and in that website suppose there is high level of security, suppose a bank internet banking website, and after suppose 5 to 10 minutes, if you are inactive in the website, it will just say that session expired, right? So this synchronization of bits, right? Or for example, again if I take the example of torrent, right? So if you are suppose downloading a torrent, if you pause the torrent at some time, and again on the next day, if you come back and you just press the play button on the torrent, it will again start downloading, right? So this synchronization of bits, how much it has downloaded, from what point it needs to download again, checkpoints, if I may call so, this thing is again controlled by the session layer. Okay. Okay. Next we have the presentation layer. Okay. So the presentation layer is actually responsible for the translation, compression, and encryption of the data. Now what is this? Let us understand. Now obviously, what do we mean by translation? So suppose we are at the sender side, we are using a for example Windows machine, right? And at the receiver side, suppose we are using a Linux machine. Okay. So Windows, obviously you know that it will the encoding scheme of Windows is ASCII, right? And the encoding scheme of Linux will be UTF-8, right? So again, if I want to send a message, if I have written a message in ASCII scheme, it can happen that the receiver who uses the UTF encoding will not be able to understand what I have written. Okay. So again, so before sending, it needs to convert the message written in ASCII encoding into a common form that will be understandable by the computer who is using the UTF encoding, right? So this conversion into a common form is known as what? Translation. Again, whenever we are sending a data, obviously there are hackers who can easily hack into networks and can steal our data. So again, encryption of data and decryption of data at the sender and the receiver side respectively is also the functionality of the presentation layer. Also, if I want to send a large file, so again compression of this data is also the responsibility of the presentation layer. Lastly, we have the application layer. So if you remember in the first diagram, we said that the user, the sender and the receiver, the persons, the human beings actually who are sitting at the sender and the receiver side will actually communicate with the application layer, right? So again, the application layer is responsible for providing services to the actual user, right? Now what are these services? It will provide higher level services such as, for example, virtual terminal. So if I want to communicate with a computer virtually, so again this type of services are given by the application layer. FTP, that is file transfer protocol, HTTP, SMTP, right? For SMTP is actually sending messages, right? So these type of mail services, again these protocols will be taken care by the application layer, which means these protocols will be offered to the user with the help of what? The application layer. Okay. So if I want to summarize whatever we have learned till now, so first and foremost, we will have the physical layer. So again, this picture will be very important just to summarize the things. So the physical layer is actually used to transmit the bits over a medium and to provide mechanical as well as electrical specifications. Why mechanical? The topology part, right? And why electrical? That the conversion of bits to signals. So these kind of things will be taken care by the physical layer. The data link layer, in this case, what it will do? It will organize bits into frames and provide hop to hop delivery. Similarly, the network layer, what it will do? It will move packets from the source to the destination and will provide what? Inter-networking. Similarly, we have the transport layer that provides a reliable process to process message delivery and error recovery. Then we have the session layer that is used to establish, manage and terminate sessions that we have discussed earlier with the example of a bank, internet banking website. And then we have the physical layer that is used to translate, encrypt and compress the data. And lastly, we have the application layer that allows to access the network resources. Now what are the network resources? These kind of things that the HTTP, the FTP, the SMTP, these kind of things will be allowed for the user to access these kind of things using the application layer. Okay. Now the second model that we will study today is something known as a TCP/IP network model. Okay. Now the layers in the TCP/IP network protocol suite do not match exactly with the layers of the OSI model. Okay. We will see what are the layers. Okay, again the original TCP/IP protocol suite was defined as having 4 layers, right? So it can there can be a question coming that how many layers are there in the TCP/IP protocol suite? It can be 4, it can be 5. Okay, so but what are these? What is the confusion? I will discuss it in the next slide. However, when the TCP/IP is compared to OSI, we can say that the TCP/IP protocol suite has mainly 5 layers. Now, what are these 5 layers? Let us see in this diagram. So, initially we can say that at the bottom we have 2 layers, the physical layer and the data link layer. Okay, but if we combine this, we can say that this layer is actually the host to network layer or network to host layer. Both things are correct. Okay. So again, if there is a question that how many layers are there in a TCP/IP protocol suite, both answers are correct, right? It can have 5 layers, it can have 4 layers. It just depends on how we see it. Okay, so both answers will be correct. Okay, so again, we can see here that first and foremost we have the physical layer and the data link layer. Again, the functions of the physical and the data link layer will be the same, which means the physical layer will be actually concerned with the actual delivery of bits or transmission of bits, and the data link layer in this case will be concerned with breaking packets into multiple small frames, right? So the functionality of this data link layer and the physical layer, and if we combine them, the host to network layer is the same as that in the case of ISO OSI reference model. Okay. Again, we have the network layer. So here we can see that the protocols that we are talking about are explicitly defined, right? So the first protocol that we will talk about is IP. That is actually the internet protocol that we have discussed earlier, and there are various other protocols as well. Something known as ARP. ARP is known as address resolution protocol. Now, why do we use ARP? It can happen that we know the IP address of a machine and we want to find out the MAC address of the machine. So for that scenario, we will use the ARP protocol. How these protocols work, we will discuss it later. Okay. Similarly, we have RARP, that is reverse address resolution protocol, which means if I know the MAC address and if I want to find out the IP address, then we will use the RARP protocol. Okay. Similarly, we have two protocols that is known as ICMP and IGMP. What is ICMP? It is known as Internet Control Message Protocol, and IGMP is known as Internet Group Message Protocol. So these protocols will be used to actually send messages to certain computers or to a group of computers, right? So for certain computers, we will use ICMP. For a group of computers, we will use IGMP, right? Again, we come to the transport layer. The transport layer in this case, as we discussed earlier, it is responsible for port-to-port delivery of packets or messages, right? So again, there are various things that are defined in the transport layer in TCP/IP protocol. One thing is TCP. TCP is actually what? Transmission Control Protocol, and second one is what? UDP, that is User Datagram Protocol, right? So using TCP or using UDP, we can deliver messages from one process to another process, one port to another port. Okay. Now there is a slight difference between TCP and UDP in this case. TCP, so these things are very essential to remember. TCP is actually a connection oriented protocol. Okay. And UDP in this case is a connection less protocol. Now what is connection oriented and connection less? What's the difference? In the case of connection oriented, whenever a computer A wants to send data to computer B, right? Which means suppose a FTP port in computer A wants to send data to the FTP port in computer B, what will happen then? The process will take place from port number 27 at computer A and it will end at port number 27 at computer B, right? So in connection oriented, what happens? So first the connection will be made and then the message will be passed. Okay. But in connection less, what happens? The connection will not be made first, the messages will be passed, right? But the connection will not be maintained during the message passing. In the case of connection oriented, the connection will be first made and then it will be maintained throughout the message passing time. Okay, which means TCP we can say is more secure because the connection is maintained during the data transmission time, but in the case of UDP we can say that it is less secure because the connection is not maintained during the data passing time. Okay, so these are certain protocols that we will use in the transport layer in the case of TCP/IP protocol. Okay, again we have session layer, presentation layer and application layer in one suite in the case of TCP/IP. And again,
Sir, can you explain SCTP once?
SCTP.
Yes, it's written in the presentation.
Okay, okay. See, SCTP is, just a second, just a second. So SCTP is actually nothing but stream control transmission protocol. Okay. So what is stream? What is a stream? Stream means again it will send data streams. Okay. Now what is the exact feature of SCTP? These kind of things we will discuss in the later half of the session. So again, for now we should understand that if we consider stream control transmission protocol, or if we consider transmission control protocol, or if we consider user data control protocol, all these protocols will be used for actually port to port transmission of the data from source to destination. To answer your question, TCP is transmission control protocol, and SCTP in this case will mean stream control transmission protocol. So how we send streams of data. So we are not sending one packet or two packets, right? We are sending a stream of packets. So how we will define that, or how we will oversee the transmission of streams of packets from the source to the destination. Again, it will be taken care by the transport layer in the case of TCP/IP reference model. Okay. Again,
Sir, then what will be the difference between SCTP and UDP? I guess UDP is also used kind of for streaming, where speed is much more important than the
UDP.
UDP. I
UDP.
mean, where's
See, all these protocols, they define the same thing, right? But how the connection is made is different. In the case of UDP, it is connection less. In the case of TCP and in the case of SCTP, it is connection oriented. So this is the only difference. Plus, there are certain more differences, very slight differences that we will discuss in the classes when we will study SCTP, TCP as well as UDP in detail. Okay, so if I am clear with that.
okay, sir?
Okay, yeah. Okay, finally, as we were discussing earlier, we have the combination of the application layer, the presentation layer, as well as the session layer as one layer, and obviously that will define what? That will define the higher level protocols like SMTP, that is short message transfer protocol. FTP is actually file transfer protocol. HTTP is actually hypertext transmission transfer protocol. DNS is what? Domain name service. SNMP, I don't remember what is SNMP. Just a sec. Telnet is again used for virtual terminal kind of things. SNMP, I guess it stands for simple network management protocol or something like that. Okay, I exactly don't remember it right now. So again, these higher level protocols will be handled by the last layer, that is the application layer in the case of TCP/IP reference model. Okay. Okay. Now, first and foremost, we will understand that what's the actual difference between this TCP/IP reference model and the ISO OSI reference model. Okay. So the ISO OSI reference model is just a standard. So that's the reason why it is called as open. Okay. Why open? Because this is a standard that was developed by the body ISO. Okay. Now what it means is that ISO governs that how new computers, right, with network models inside them. So suppose we have a OSI model inside them. So how new computers must behave when connecting users to a network. Okay. So this is not an actual model that the computer will follow, but it will govern that if a computer needs to connect to a network, or it needs to send message from one machine to another machine in a network, how it should behave, right? But in the case of TCP/IP reference model, not reference model, but only TCP/IP model. TCP/IP model is the actual model that we use in our day-to-day lives in our computers. Okay, so if you just go to your network settings, and if you want to change your IP address or something, so again you will always see TCP/IP v4 or TCP/IP v6. So this is the actual model that we use, right? In the case of OSI, it will govern, or it will tell you that how the reference model should behave, or how, if I want to create a new reference model or network model, how the network model should behave when it is connecting to a network, or how a network model should look like whenever we are connecting to a network. Okay, but actually in the real time scenario, we do not use the OSI model because that's the standard but actually we use what, the TCP/IP model that was developed by ARPANET. Okay, and this is an actual network model that is used by computers when connecting to a network. Okay, so this is the main difference. There are certain other differences as well. You can always search Google and then you can find out various differences. There are certain differences like it contains 4 layers, it contains 7 layers. So don't go into those details, but there are various other details as well. So you can always search Google and find it out. But this is the main difference. So whenever a question comes that why it is called as open system interconnection, why it is called as open, because that's the open standard that needs to be followed whenever we are defining a new network model. Now TCP/IP in this case was a new model that followed the standard of the OSI and is actually used nowadays in our computers. Okay. Again, as we were discussing earlier, there are four levels of addressing. First is physical address. Physical address is what? The MAC address that is governed by the data link layer. Again, we have a logical address, that's the IP address that is governed by the network layer. Then we have the port addresses, which means process to process delivery of packets. So there will be various ports inside our computers. Why? Because there are various processes running inside our computer. So again, these port addresses will be governed by the transport layer. And lastly, there are specific addresses, which means if you remember this diagram, so in the application layer you can see that there is something called as a DNS, right? So what is DNS? That is domain name service, which means if I type in URL, for example, if I type in google.com, so what is google.com actually? Google.com is nothing but it will, whenever we type in google.com, it will go to the DNS service, and DNS service, what it will do? It will have a database. It will just find out that google.com, www.google.com refers to which IP address, and then what it will do is it will just fetch the server at that IP address, and then it will fetch data from that server and give it back to us. Okay. So if I say specific address, again specific address in this case will mean what? URLs that actually we use, and actually they are made converted into IP addresses using what? The domain name service. Okay. Again, we can see here that we have various layers in the TCP/IP reference model, and these addresses are corresponding to which layer. So we have discussed earlier as well that the physical address will actually be taken care by the data link layer. We have shown both, because the data link layer as well as physical layer in the case of TCP/IP is actually the same thing. Okay. Again, the logical address will be taken care by the network layer, which means IP addresses and all these kind of things. The port address, the port to port communication will be taken care by the transport layer, and again the specific addresses like URLs will be taken care by the application layer with the help of the DNS process, or the DNS higher level protocol that is actually there in the application layer. Okay. So with that we will come to the end of this this class. So we have 7 minutes left in this class. So again, in your WhatsApp chat, I have given the IMCRP exam code. Is everyone able to see that? Just check. Just check and confirm once. If not, just wait a second, I will give you the IMCRP exam code. Just a second. Okay, so in the chat box I have pasted the IMCRP exam code. Yes, Manish Pandey has already posted it. Okay, so again you can go and give the exam, because attendance will be taken through that IMCRP exam. Okay. Okay, then I will be here in the class till 10:20. If you are having any problems regarding today's class, you can just stay back and ask me. Also, this PPT as well as the live lecture link will be posted in the Google Classroom. Uh, so just wait for today in the evening you will get it. And also the remaining PPT of day 1 again it will be posted to the Google Classroom. So if you have any problems, kindly ask me. 5 minutes are remaining. I will be there till 10:20 in this meeting.
Sir,
Tell me.
sir, when I am logging in IMCRP, it says you are not an authorized user, and after that, it is saying you have been logged out successfully.
Okay, so this is the mail ID that the mail ID that you are using. That is the mail ID you have used to log in to create your account in IMCRP.
Yes, sir.
The enrollment number is correct that you are giving.
Yes, sir. Enrollment number is correct, sir. Earlier it was okay, sir. मतलब इससे पहले तो हमेशा हो रहा था, sir.
Okay. Okay. Tell me your roll number.
Sir, 162.
162, right? Okay. Just try till 10:20. If it's not working, then I will have to give your attendance manually, I guess.
Okay, sir.
Okay.
Sir,
Tell me.
the same thing is showing again and again.
Okay, so your roll number is 162, right? I've noted
Yes,
it.
sir.
I've noted it. I will
Yes,
try
sir.
and give it manually. Don't worry.
Thank you, sir.
Okay.